In this video, we will continue to practice solving triangles using the law of sines when we are given the ambiguous case. The ambiguous case is when we are given side-side angle. When you have two sides and the non-included angle, it's ambiguous, meaning we're not sure what situation we actually have, because depending on the length of the sides, you might be able to form no triangles if the side is too short, or you might be able to form one triangle, or it's possible that we might be able to form actually two triangles. So it's ambiguous. So as soon as you notice that you're given two sides and an angle, here's what I would recommend. Put the angle here on the lower left side of your diagram. So this is angle C, so let's go ahead and label this as the angle that we're given, 145 degrees. If this is angle C, that would make this side C over here, so this is going to be 33. Now I'm making this a dotted line because we don't know if this is going to be long enough to reach the ground. We don't know if this is going to make a triangle at all, or maybe it'll make two triangles. We don't know. So I'm making it a dotted line so we can move it around. It's sort of temporary. But anyway, if this is angle C, this would be side C. And now the other side you're given, I would put right here on the left side of the triangle. So I'm going to go ahead and make this side B and call this the 7. So if this is side B, then that makes this angle B. And if this is angle C and this is angle B, that means this would have to be angle A. So that's how I would set up the picture as soon as you see that you have two sides and an angle. Okay, so now we can see that we have side-side angle because it's two sides and the non-included angle. So we know that this is the ambiguous case. So what you want to do is take note of the information you have and the information that you still need. So as far as angles that we're missing, we are going to need the measure of angle A. We're going to need to find the measure of angle B, which is missing. And we are going to need to find the length of side A, okay, which is across from angle A. So we'll need to find the length of side A. Okay, so in the end, we should have all three of these values in the box right here. Now it's possible that we will only have one triangle, depending on the lengths that we find. Maybe there will be no triangles, maybe there will be one triangle, or maybe there will be two triangles, but we'll get to that in a moment. To decide how many triangles there will be, we need to know the height. So let's take a moment and calculate the height. Okay, so the height of the triangle, if I'm going to call this h for a minute, we can use the sine function and look at this right triangle that's over here on the left-hand side. So 145 degrees. If we say the sine of 145 degrees, if we look at that, that's going to equal opposite over hypotenuse. So this will equal h over 7. If we multiply both sides by 7, then we will get 7 sine 145 is equal to that height. We can just put this into the calculator real quick. 7 sine 145. Okay, and we get 4.015. Okay, that's the height. Okay, so if this height is 4.015, then that means we will definitely have a triangle. All right, we have at least one triangle because this side over here, the temporary side, the flexible side, is 33. It's definitely long enough to reach the ground. All right, if this is a little over 4 units high and this is 33, it'll reach the ground. So we will have at least one triangle. The question is, will we have two triangles? The only way we would have two triangles is if we were able to take this side and swing it around and hit again on this side to make another triangle. So that's how you get two triangles. If you have one triangle in this position and then you have another triangle in this position. So would this make sense? The answer is no. We will not have two triangles this time because this is 33. All right, the swinging side is too big. If this is 33 and this side right here is only 7, there's no way that a side of 33, which is bigger than 7, is going to fit inside the triangle. The only way it's going to fit is outside the triangle like this. All right, so in this case, we are only going to have one triangle. And we can go ahead and solve this using the law of sines like we've done many times before. So looking at these sides that are across from each other, this angle and its opposite side, we can say the sine of 145 degrees over the sine of, no, not the sine of the angle over the opposite side, so over 33, is going to equal a similar ratio for another angle. So since we've got this 7 over here, let's go ahead and use it. And we can say the sine of angle B. So we can solve this to find angle B. If we multiply both sides by 7, so these 7s will cancel out. That's going to give us the sine of angle B will equal all of this. But we don't want the sine of angle B, we want angle B. If you want the actual angle B, you have to do the inverse sine. So we can say the inverse sine of all of this, okay, 7 sine 145 over 33. The inverse sine of all of that will give us the measure of angle B. So just put all of this in your calculator and that will give us the measure of angle B. So here I've put this all in my calculator like this, and I'm getting 6.988. So that is the measure of angle B, is 6.988 degrees. Okay, so this is 6.988 degrees. Now that we have the measure of angle B, it would be easy to find the measure of angle A. We just subtract these two from 180. The total has to be 180. So we just go back to the calculator and we do 180 minus 6.988 minus 145, and we get 28.012. So this is 28.012. And all we need to do now is find side A. So if we want to do that, we will do the law of sines again. All right, so if this is side A and this here we have angle A, we can say the sine of angle A, actually, you know what, let me start off using the exact same ratio that we did before. All right, I'm just going to set it up the exact same way. So I'm going to say the sine of 145 over 33, okay, using the 2 that we were given in the first place, the angle and the opposite side. And now I will do the a's. So now I will say the sine of 28.012 over side A. These should be equal. This is the law of sines. If I cross multiply, I will have A sine 145 along this diagonal, and this diagonal gives us 33 sine 28.012. Dividing both sides by the sine of 145 gets A by itself. Okay, so these will cancel each other out, and this will give me A. So I can just put all this in my calculator. Sine 28.012. And I'm getting 27.012. And that is the one and only solution for this triangle. Let's go ahead and do one more problem on this video. Again, as soon as I see that I have two sides and an angle, I'm worried that this is going to be the side-side angle, the ambiguous case. So take your one angle and put it on the lower left-hand side of your triangle. So I'm going to call this angle B, and I put the 73 degrees right here. If this is angle B, that makes this side B, so I'm going to take that 5 and put it here. Now, if this turns out to be the ambiguous case, then this is going to be my variable side, my swing side. That's why I made it dotted, because we don't know. Well, it might be here, it could be here, or it might not exist at all. So the other side, that's going to be length 7. Let's go ahead and put that here, okay, on the left. So if that is side A, that makes this angle A down here, which makes this angle C up here. So we see that we do have the side-side angle situation. So this is the ambiguous case. We might have one triangle, we might have two triangles, or we may have no triangles at all. So let's think about the information that we're going to need. We have one angle, but we're missing the other two. So we're going to need the measure of angle A. We're going to need the measure of angle C. And we're going to need side C, which is the missing side. All right, so assuming there is a triangle that we can make at all, these are the three values that we're going to need. First thing we have to do is figure out whether we can make a triangle at all. So to figure that out, we need to find the height of the triangle, so we can see if this swing side will even reach the ground. So if this is the height, I'm just going to call this H for height. We can calculate this height using sine. So the sine of 73 is going to equal opposite over hypotenuse, so that would be H over 7. If I multiply both sides by 7, then I get 7 sine 73 is equal to the height, If I put this in my calculator, I get 6.694. So the height is 6.694. So the question is, can I make a triangle at all? Now, my swing side over here is only 5 units long. So we are not going to be able to make a triangle. Let me see if I can ungroup this so I can demonstrate better. My computer's moving really slow. All right, so look at this swing side that we have. Okay, this is length 5. Now, if the height of the triangle is 6.7 approximately, then this height of 5 is not going to quite reach the ground, is it? All right, if this is only 5 and the triangle is 6.7 long, this side is too short to reach the ground. It's too short to form a triangle. So we will have no triangles at all, so we will just have no solution. All right, that's going to do it for this video. I hope it was helpful, and I will see you on the next video.